Just to introduce myself, so my name is Joachim Fuchs. I'm head of the Software Systems Division of the European Space Agency. It's the first time I'm at the Flight Software Workshop here. I'm actually very excited and saw a lot of very interesting things and had interesting discussions. I'm also happy that there are some positive remarks about what ESA does. So means we can also contribute to that discussion. When I came here, I was afraid that I would hear that CFS is the panacea to all our problems. After the first 2 days, I'm glad that we're all struggling with the same problems. So we don't have the full solution for all our problems yet. What is interesting to observe is that there is a different approach between pushing for CFS, what NASA does for the future missions, which is more on the product side, and we in Europe, we are trying to push more on the standardization on the interface and specification side. It's two different approaches of trying to solve the same problem of interoperability, which is one of the things we are all struggling with. So I was glad that yesterday the first elements of model-based approaches were highlighted, and also some of the discussions today and reactions I got concerning my remark on the RN5 failure, when I had to explain, yes, it was a buffer overflow, but at the end of the day, if you go to the root cause, some of that was a specification fault. These things lead us to actually investing into the side of specification and how can we formalize that, how can we improve that, and how can we use that in order to improve the quality of the software we are developing. So, context of what we are doing briefly, and then the focus of my presentation will be on the tool sets we have been developing over the last couple of years, and some conclusions. I'm not going into the detail of this. This has been presented last year by a colleague of mine, Marek Bochacka, and it's just a very brief summary of what our definition of packet utilization is. It's services defined in a standard, in an ECSS standard, and Jonathan Wilmot here has made, in the frame of CCTSDS, a very nice mapping between CFS services and PUS services, and here, as he was pointing out on the first day, actually we in PUS have services which might be useful for CFS and vice versa. So we have to look at each other and actually try to see what we can learn here. I still want to make a little history to the PUS standard because it's important to understand what we did and why we can do what we do with this model-based approach now. The first definition of the packet utilization stems back from '94. It was before we had a standardization body. But then we created something called ECSS, European Consultation of Standardization, Space Standardization, and that created the first version of a European standard, which we called PUS version A. That already included a lot of lessons learned from this first definition of the packet utilization. In 2016, we had an update. This update was very fundamental. It's not only that it improved, removed some errors, removed some services, introduced some new services, but it also changed the structure of the document. And I come back to that. So we have now, from a thin booklet, which it was before, we have a document of more than 600 pages. We have more than 3,000 requirements in that document. But what's much more important, we have a fundamental different structure of this document with respect to before. we have something which is called a generic foundation model, which really tries to capture in a formal way the PUS is defined and proves that it is consistent. And from that generic foundation model, we're deriving system specifications and interface specifications. But of course, we have a problem with that, which is how can we deal with that complexity? So it was important to address the way can we use tools in order to do that. Because what has happened for the standard as it stands today, so 2016, it is we had this PUS foundation model. This is a formal model. The methodology used for that was the ORM, Object Relation Models. And then it was a manual instantiation of the 20 services to produce at least parts of the system specification and the interface specification. So we have been using this knowledge placeholder, this foundation model, to verify this, but it's still, there was still quite an effort in producing that overall standard. So what we needed is really to come up with some tooling to support that process, and not only for the standard, but also for the missions. The goal, how to see it, automate the process. The goal is to take the PUS foundation model, have a tool which helps us populating, have a tool which helps us tailoring the PUS, and come to a database which is what we call correct by construction and represents all necessary information for command control for our spacecraft. So the tool, by using these formal methods and tools, will only allow you to instantiate an interface definition and a specification for your command control, which is correct by construction. So the tailoring itself, it's the addition, removal of services. The standard allows to define new services because we cannot define all the services and every mission will have their private services. However, it is necessary to ensure that all new services are compatible and in line with the foundation model so that they are fitting into the overall command model. But also the population with mission-specific data is part of the tailoring. So also list of APIDs. And with the tooling, we are able to ensure the consistency of all that data. So what we want to have at the end is this formal model, this database, containing the full specifications. But here we are coming to another point, another discussion we had also yesterday. Models for the model's sake, there is no use. So for me, it's important that we know exactly why do we want to create those models. Models are relevant when they can be used for something. Because we, as an old modeler and simulation guy, my mantra was always there are a lot of models. Models are always wrong, but some of them are useful. So we have to be sure that we can find the proper uses and make the models so that they can be used for their purpose. And in the case of this PUS modeling, what we did was really, we wanted to have a possibility to generate artifacts which are useful for our processes. Start with producing a clear specifications document. Again here, some people may say, but the model is the specification. No model I know of is useful without a narrative. We need to have human readable artifacts generated by models. And so we want to have human-readable requirement specifications generated from the model. We want to have ICDs, also human-readable, but ICDs which we can also use to generate code. We have the objective to generate software out of this model, and software which can encode and decode killer commands, but also which may implement some of the behaviors which we have defined in standard. And finally, generate test cases out of that. So how do we do that? And here I would have had a small video running through that process, but it takes about 8 minutes, and I thought I just mention the main steps here. I can show that in a break if somebody's interested. But the tool we have developed has basically this is one of the main interfaces. On the left side, you have the list of available Plus services and the possibility to define your own services. Whatever is defined here is consistent with the foundation model. Whatever is documented here is automatically forcing you to fill the fields which is required to define the service, and you will have on the right side the definition of your project-specific configurable data. So with this tool, it is ensured that whatever is defined on this side and all the services, sub-services are complete and consistent with the foundation model. Next step is then the tailoring, where basically from that list you select the services which you need, which are required for your particular mission, and you give this project-specific data like the API ID, failure, and then the magic happens. You press the button, and all those artifacts I was talking about before are generated automatically. So here it's an example. The document generated by that is a full specification of the PUS C services for your mission. It has the format, exactly the same format as the standard. It has the same structure, it has the same layout, it has the same wording. It is the full formal specification in a human-readable form of your PUS C services. The next element is that you have the ICDs being generated either in the form HTML, or it is an ASN1 code which is generated on this side. ASN1 is a ITU standard, ITU and OSI standard to define communication protocols. And we have then a tool suite which is called Taste, which is open source, taste.tools. Everybody can download it, which allows us from this to basically generate artifacts of flight software. However, that's not where we stop, because that was at protocol level. The standard also defines some service behavior. Just as an example here, for example, the functional monitoring function sets the F1 function to enabled. For each functional monitoring definition that is enabled, set the F1 checking status to unchecked, start the monitoring of the monitoring definitions. So that's an example of where a behavior is defined in a standard. So what we're working on is to see how can we also formalize this. This is STL, is an example, the specification specification description language, which is also an ITU standard, which is allowing to describe in a formal way connected state machines. So each of these boxes is actually a state machine, and they're talking to each other. So we have the means to describe the behavior in each of these state machines, and the messages to be exchanged between the two, which is exactly what we want to do. And it allows you to produce also, again, flowchart-like, human-readable specifications and descriptions of your behavior, keeping in mind that these are models, these are not drawings. So this is generated out of the formal specification, out of the modeling exercise, and out of that we can generate code and test scripts. So in a nutshell, this whole exercise, which was taking the PUS standard as it is defined today and benefiting from the effort we have put in formalizing this foundation model, we were able to, first of all, give formal feedback to the standard of a number of things which have been highlighted and have been identified as not being fully correct. I think, considering the amount of manual work which still was going into the standard, to only find 21 changes for 3,000 requirements, I think that is a good measure. And we were able to generate tools and develop tools which are able to hide the complexity of the PUS standard and allows to the mission designer to focus on the semantics of the services, on the definition of the services, and then have a tool chain which actually supports the generation of all the artifacts which are necessary in order to produce flight software in our systems. So for me, this is just a start. These tools we are just in the process of actually accepting them. They are just, the development has just finished, so it's fresh from the press. But once we are happy with them, we will consider including them in this TASTE tool suite as one of the building blocks supporting model-based flight software development, model-based safety-critical software development. Yes, and since I'm not necessarily the expert of that, I hope there aren't too many detailed questions.
Questions?
Okay, got frightened away.
Sometimes you have to wait just like 30 seconds.
Yes, I was just wondering how far you go from building the code. Do you go and do the requirements traceability all the way to your test?
Is your question more concerned with the traceability or?
Traceability.
Yes. No, with the traceability, these tools, the reference I made to these TASTE tools, they are using, the idea behind is that you're using a common model to generate all the artifacts. And through the tool chain, you're basically always tracing back to the source of your information. We are not using additional tools, at least in this process, separate tools to establish a separate traceability between the tests and the requirements. This is something which we are looking at in a different context, more at system engineering level, where we try to see in how far we can use system models and their derivation into the functional architecture, into functional modeling, to trace back the verification results to the requirements. But this is not specifically for the software. We're doing that. I don't know if that answers your question.
Okay, I guess that leads me into another question I had. So is this used for operational software or just at the desk of a system engineer, say, just testing what the system should do?
No, this is to produce real flight software.
Okay, thanks.
So the tool chain, This particular, the push-seat tailoring tool, we have not been used in a real project. However, everything, the machinery behind, certainly everything from the ASN1 to flight code, is, for example, used in our program, in one of our program missions, which is being developed at this moment. It's also, parts of that is being used in the KEOPS mission, which is going to be launched next week.
Other questions? You have one?
So kind of as a follow-up to his question, or maybe it's more of a comment, I mean, since the tool does do all that traceability, it shouldn't be hard to create the traceability artifacts then, you know, especially for those of us that come from the whole manual way of doing it in the past, you know, so you could check them off. Is that fair?
Absolutely agreed, yes. It shouldn't be a problem, because the information is there, yes. And it's like this, well, I say, once you have the model and you know what artifacts you want to generate, it is to build the machine which basically does the model transformation and extracts the information from the model which you want to have. But the information is there in the model, yes.
Okay, other questions? Okay, great, thank you.